Hello everyone, welcome back to my Learn Easy Maths channel. Friends, how are you? I hope we are all meeting again after a long gap and long period of time. Because of my some personal busy schedule, I could not make the videos and I could not interact with you by appearing on the video. Now today I have come back with some more new concepts and some more new topics. Today our topic is general. I would consider it as general. You may be surprised enough to know that what it is a general. Because general today I have brought some algebraic. Today I would like to discuss some algebraic identities with you. See, algebraic identities is just like as a backbone of our almost all the mathematical calculation, particularly which pertains and related to the algebraic calculations. Okay, so identity is going to play a very vital role in our calculation, in our solutions, whether it is a equation, linear equation, or it is a quadratic equation, or it is a cubic equation, whatever it may be. The degree doesn't matter, but identities are going to play important role in this one. Now, today we will start a very simple, very common, and also it is a very popular identity. The first identity is called a plus b whole square. Means a and b are the binomial. What is binomial? These are the two terms in algebraic number. A is an algebraic value, b is an algebraic value. We can say it is a variable. Variable is a number which do not represent or which do not possess a definite value. So that's why we say that a plus b whole square. How do we expand this? A square plus 2ab plus b square. This is the expansion of a plus b whole square. Sum of the two terms whole square is the square of the two terms plus twice the product of the two terms. Square of the two terms means what? A square plus b square, and twice the product means a and b into 2, that is twice the product of the two numbers or two terms. Okay. There are some manipulation which I am going to show you here. Okay. This a plus b whole square is equal to a square plus 2ab plus b square, or a square plus b square plus 2ab is equal to a plus b whole square, because LHS is equal to RHS. When you just interchange, RHS is equal to LHS. Now what do you find? Suppose I want only a square and b square to be. A square plus b square is equal to a plus b whole square. Then you transpose this or shift this 2ab to the right side of the equality, that is equal to, it changes to minus 2ab. Now a plus b whole square is a square plus 2ab plus b square. Then a square plus b square is equal to a plus b whole square minus 2ab. This is very simple and very easy. Now I want some more manipulation in this one. A square plus b square is equal to a plus b whole square minus 2ab. First one is a plus b whole square is equal to what? A square plus 2ab plus b square. Now I want what is 2ab? Right. Take this one. A square, this is second manipulated form. This is the second. A square plus b square plus 2ab is equal to what? A plus b whole square. But I want 2ab. What is 2ab is equal to? 2ab is nothing but a plus b whole square minus a square plus b square. This is the answer. Only actually how many terms we have in expanded form, friends? We have sum of two terms. When we expand, we get three terms, isn't it? Because what is degree? A plus b whole square. When you square it, you get three terms. 1, 2, 3. When you cube it, you get four terms. Are you following? When you just raise it power 4 times, you get 3 terms. When you raise the power to the 5 times, you get how many terms? 6 terms. When you raise the power to the 10 times, you get the 11 terms. When you raise the power to n time, which is called binomial theorem, when you raise the power sum of the two terms to the n times, it will give n plus 1 term. Remember, okay? A plus b whole square, when you expand it, you get 3 terms. A square plus 2ab plus b square. Got it? Similarly, a plus b whole cube, when you expand it, a cube plus 3a square b plus 3ab square plus b cube, you get 4 terms. Similarly, when you expand the sum of two terms power raised to the n times, its number of terms in expanded form will be n plus 1. I hope you understood it. Okay. Let's we take one example and we will just apply this. A plus b whole square, 2 plus 3 whole square. Assume it is a square and it is a and b. A square plus 2, a is 2, b is 3, b square is 3 square. Why it looks very simple, no? Because every simple thing has a very substantial concept. I repeat it. Every simple things has a tremendous and also very substantial concept. For example, see our Euclid's axioms and postulates. Equals are added to the equals, the wholes are equal. What is a great thing? Now it looks long, very simple things. When you go deep in that one, equals are added to the equals, the wholes are equal, it gives a very substantial concept. If equals are subtracted from the equals, the remainders are equal, then what is a great thing? Not a great thing, but the concept is very great. So that's why I say that every simple thing, though it looks very simple, but it has a tremendous and substantial concept in it. So I have expanded here a plus b whole square means in place of a I have taken 2, in place of b I have taken 3. Then I expanded a square, 2 square, 2ab, 2 is a formula number, it is in formula, 2 into 3 plus b square. Now you expand. What is 2 plus 3? 5 whole square. When we make the calculation, make the sum and square, do we get 5 square or not? Let's see. 2 square is 4, 2 2s are 4, 4 3s are 12. 3 whole square is 9. What is 5 square? 25. When you make the sum of all these products, 4 plus 12, 16, 16 plus 9 is 25. Therefore, a plus b whole square is equal to a square plus 2ab plus b square. Isn't it? Yes, it is verified. Verification number 1. Now, I told you what is a square plus b square is equal to a plus b whole square minus 2ab. Apply that also. A square 2 whole square plus b square 3 whole square is equal to a plus b whole square 2 plus 3 whole square minus then what we have taken 2 into ab minus 2 and a is 2 and b is 3. Okay, now you take this one. What is 2 square? 4. What is 3 square? 9. 2 plus 3 is 5 whole square. 2 2s are 4, 4 3s are 12. Friends, are you all following now? Am I a little bit fast? Should I slow my pace? Okay, you please you are not giving any comments at all. That is a problem. You watch my videos friendly, you watch my videos just very recently, or you watch my video unwillingly. I don't know. The choice is left to your side. So please, if you are watching the video with great interest, you please put a comment that what are the defects, what are the effects, what are the positive, what are the negative. These are all matters, no, so that I can make still more improve in my presentation. Now, 2 square is 4. 3 square is 9 is equal to 2 plus 3 5 whole square minus 2 2s are 4 4 3s are 12. If I add LHS, my sum must be equated to the RHS, both should be equal. 4 plus 9 is 13 is equal to 5 square is 25 minus 12. What is 13 is equal to 25 minus 12 is 13. Yes, this identity is also verified. Which identity? A square plus b square is equal to a plus b whole square minus 2 into ab. And this identity is also verified. A plus b whole square is equal to a square plus 2ab plus b square. Is it clear? Now the third one to be verified. Why I am giving this means these are all the applications make the child to grasp in logical reasoning. See, a plus b whole square means the child does not follow at all what is a and b. First of all, he should know that what the a represent and b represent. If we explain him in the identity, first of all, the child may not be able to understand, or child may not be able to define what is an identity. Even many elders are only not in a position to define what is an identity. That too, there are two types of identities. One is clear and unconditional identity. One is a conditional identity. These are all the complex things involved, friends. That's why, in order to make our child in a very, very simple, easy, and in a comprehensive way, we have to give this example. Particularly, primary teachers and the children's and whose children are in a primary level, if you show this video, they will understand what exactly the concept of a plus b whole square. The third verification is remaining. What is that? 2ab is equal to what? A plus b whole square minus a square b square, right? 2, a is 2, b is 3, because in place of a and b we have taken 2 and 3, remember that one. Okay, sorry. 2ab, a plus b whole square, 2 plus 3 whole square minus 2 square plus 3 square. You follow the bracket also, because BODMAS says that only bracket of division, multiplication, addition and subtraction. Whole mathematical calculations are based on the BODMAS. If you make left and right, up and down, little just comma, semicolon disturbance like that in BODMAS, your calculation and your answer will be entirely different. That's why you have to take care of the BODMAS also. See, 2 2s are 4, 4 3s are 12 is equal to, what is 2 plus 3 whole? 5 whole square minus 2 square is 4, 3 square is 9. This 12 is equal to 5 square is 25 minus 13. 25 minus 13 is 12 and 25 minus 12 is 13. See that 25 minus 12 gives the value of a square plus b square. 25 minus 13 gives the value of 2ab. Isn't it? And 4 plus 12 plus 9 gives the value of 2 plus 3 whole square. I hope you followed this very easily. Is it clear? Now this is the first identity of our algebra which I explained before you. Here I am going to some more identities related to this one, and you please follow it. A plus b whole square, the second one is a minus b whole square is equal to a square minus 2ab plus b square. Alright, then next a plus b into a minus b is equal to a square minus b square. Sum of the two terms and into difference of the two terms. A and b sum and a and b are difference, and when they make the product it is equal to a square minus b square. Similarly, we have another identity, that is x plus a, x plus b, which is equal to x square plus sum of a plus b into x plus ab plus ab. These are the square identities which I showed you. Okay. Here sum of the two terms and their square, a and b, or any algebraic number you take in two terms. Now I am going to take three terms here. A plus b plus c whole square. Here the three terms squares are here. Then how to expand it? Very simple. First take the squares of all the three terms. A square plus b square plus c square. I am continuing down now. 2, first make the product of first two, ab, plus 2 make the product of second and 3, third bc, and make the product of third and first 2ac. So this is the expansion of what? A plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ac. This is the way that we can expand very easily. Okay, with this one, now we are going to end up our square identities of 2 terms and 3 terms. This is the first video, still many more identities to be explained. And my dear friends, viewers and students, whosoever may be watching this one, please do not forget to follow this one, particularly show the children. And children, if you are watching, you please practice. I have taken an example of 2 plus 3. You can take any number of terms, any number for this expansion. You can take 4 and 6. You can take positive and negative. You can take the rational numbers also. Everything, it is a unconditional identity. It holds true. It is applicable and it is good. It holds good for everything. A plus b whole square is equal to a square plus 2ab plus b square is an unconditional identity. But still we have some conditional identity also. But in my next video, inshallah, I will tell you what are the conditional identities in the next week or in the future to come. Please do not forget to subscribe my videos. My friends, my viewers, my colleagues, my teachers, my family and my family friends and their friends, because it should be a continuity chain. And 10th standard student teachers may understand better that when you share the video, you become a carbon. Don't become any other element. You become a carbon, because carbon has a tetravalency. It has 4 bonds. Carbon shares 4 bonds with all other elements. Similarly, you should also, each one of you should share the video to 4 friends of yours. So each one of you 4 means 4 for the 16. Yes, and 16 for the 64. It's going to make a multiple formation. With this one, here I am going to end up my video with hope that in the next video very shortly we are going to meet. Take care. Bye bye. Thank you.